are solving such an integral, tan arctan of x out of 1 plus 1 out of x squared is equal to an integral of tan arc of x. So we are going to first solve this lower the denominator, whereby you get x squared plus 1 out of x, yes, out of x squared, dx, yes. So this is the same as, so when you divide tan arctan of x divided by this whole thing, you are going to get the integral of arctan of x times, this is times sign, times x squared out of x squared plus 1 dx, yes. So this is what we are going to solve. So this one we are going to use what we call this formula u dv is equals to uv minus v du. So I'm going to use this formula called the integrating factor, yes. So hereby my u is equals to tan inverse, will be this first one of x, yes. My u will be this first one, tan inverse of x, is the same as, so my du, if I differentiate this, I'll get 1 out of x squared plus 1, yes. Then my dv will be x squared out of x plus 1, yes. So if I integrate this to get a v, this one will become what, dx. So this one I'll introduce plus 1 minus 1 so that I can easily solve it, plus 1 dx. Then afterwards it will become this x plus, I'll separate the two expressions, whereby here first one will be x squared plus 1, yes, it will be x squared plus 1 out of x squared dx, this one here, minus integral of 1 out of x squared plus 1 dx. So this is 1, so integral of 1 minus integral of 1 out of x squared plus 1 dx, and here it is dx. So when you integrate 1, you get x minus this one. After you integrate this one, you get tan inverse of x, yes. That means this is my v. So I have my u, my du, my dv, and my v. So we are going to put in this formula called the integrating factor. So I'll have my u, which is tan inverse of x, dv, which is dv, my dv to be this one, the same expression as this. So I get x squared out of x squared plus 1 dx, yes. So this will be equal to my u, where is my u, tan inverse of x, times my v, which is x, minus tan inverse of x, minus the integral of v, my v is x, minus tan inverse of x, yes, du. What is my du? My du is tan of x, is this my v, which is this, then my du, which is this, 1 out of x squared plus 1 dx. So this will be equal to, if I open up the brackets, I'll get, this will become x tan inverse of x, tan inverse of x times tan inverse of x, b minus tan inverse of x squared, yes, minus, so we are going to integrate this. Before you integrate, you can still open up the bracket, so that x times this, you get x out of x squared plus 1 minus integral of tan inverse of x times 1 out of x squared plus 1 dx. This is also dx. So we know that this is equal to this expression is equal to the half. If we integrate this, we get a half ln of x squared plus 1. Yes, hope you are together, because if this ln means when you differentiate this, become 2x out of the same expression x squared plus 1, whereby the 2 cancel these 2 to go back to this. So this one will come to this. So this other one, we first let it be what? Be a. And then later it can be a. Yes. So you're going to integrate this one. Whereby we shall also use an integrating factor, and whereby my u is equals to tan inverse of x. My du is equal to 1 out of x squared plus 1. Yes. Then my dv equals to 1 out of x squared plus 1. And my v, integrate this, I'll get tan inverse of x. Yes. Hope you're moving on. Hope you're moving on swiftly with this. Yes. So afterwards, here we are going to integrate this. So I'm going to have my uv. First write the formula here so that you don't forget. It is uv minus integral of v du. So my u is tan inverse of x. My v is tan inverse of x minus integral my v is just tan inverse of x. Then my du is 1 out of x plus 1 dx. So but you realize that this expression, this integral, is the same as this. So but this one we labeled it as a. That means also this one is what? This one is also a. But this one we are finding the integral of a. Yes, that means this one will be a equals to tan inverse times tan inverse of x, get tan inverse of x squared minus a. Yes, so that means this a, if this a comes this side, you're going to get my 2a equals to tan inverse of x squared. Yes, then after that, divide by 2, we divide by 2, whereby my a will be equal to a half of tan inverse of x squared. Yes, hope you're moving on swiftly with this. So the next step we are going to do is that we have gotten our a here, so we are going to write our this expression that we had. Since we have this answer, we have the integral of this, which is a half ln x squared plus 1 magnitude minus a, whereby my a is a half tan of x squared. So my final answer will become x tan inverse of x minus tan inverse of x squared, yes, minus a half ln of x squared plus 1, yes, minus my a, whereby my a is what? A half tan inverse of x squared. Yes, so after this step you realize that this tan. Yes, so sorry for what happened, because I'm sorry because I made a mistake. When you're introducing this negative inside here, you're going to remain with minus x, which is here minus x out of this. So this minus and minus, we get a plus here. That means also here down, we shall do what? We shall get a plus here. Yes. So after you realize that this is tan inverse of x squared, and this is also tan inverse of x squared. That means this and this are the same. So this is minus. If this is x, you can say minus x plus a half x. So the final answer is going to become x tan inverse of x. So this minus plus a half, we get minus a half tan inverse of x squared minus this, which is a half ln or natural log of x squared plus 1. So after getting this answer, you don't forget writing your integrating factor. So plus C is the what? The integrating factor. So this is our final answer. This is the equation. This is a plus c, whereby the c is the integrating factor. So thank you very much. You can subscribe and leave a like button if you like the video.